Hello, today we're beginning Unit D. We're starting with Lesson 4.5. We're going to solve quadratic equations by finding the square roots. A number r is the square root of a number s if r squared equals s. A positive number s has two square roots, written as the positive square root of s and the negative square root of s. The positive square root of a number is also called the principal square root. So really quick, if I have the square root of 100, technically I have two answers. I have positive 10 and negative 10, because positive 10 times positive 10 gives me 100, and negative 10 times negative 10 gives me 100. This expression is called a radical. This is a radical sign, and the number underneath s is called a radicand. There are two properties. There are the quotient property and the product property. So basically, if both radicands are underneath the square root sign, you can multiply them together if there's a multiplication sign between. And if both are underneath a radical, you can divide them as long as the division sign is under the radical as well. Square roots. A square root expression is simplified if no radicand has a perfect square factor other than 1, and if there's no radical in the denominator. Okay, so we're going to go back to first year algebra and refresh your memories on how to simplify square roots. So when you get good at them, like what you can say in your head is, what's the biggest perfect square that divides into these numbers? So for example, square root of 4. Yep, 4 divides into 80. Let's see if there's something bigger. 9. Nope. 16. Yes. Kind of run through your head and see if there's anything bigger. Okay, so what this ends up being is I know the square root of 16 times the square root of 5 equals the square root of 80. I know what the square root of 16 is because I'm pretty familiar with my perfect squares. So that's 4 root 5. That would be my answer. When you get good at this, I won't even need to see this middle step. Now, if this was a little confusing for you, what we can do is we can make a factor tree. So give me any two numbers that multiply to give me 80. 8 and 10. Now, give me any two numbers that multiply to give me 8. 2 and 4. Now, I'm going to stop at 2 because the only thing that multiplies to give me 2 is 1. So 1 times 2, so we stop there. 4 is 2 times 2. We stop again at the 2 because they're prime. 10 is 2 times 5. Then what I do is I write my square root. Any number that I see 2 of, I cross 2 of them off and write 1 on the outside. Cross 2 of them off, write 1 on the outside. Any leftovers go on the inside. Now, if I ever have more than one term on the outside or more than one term on the inside, we multiply. So I still get 4 root 5. Okay, I'm going to show you a factor tree over here as well. So I know that 2 times 49 gives me 98. And I know 49 is 7 times 7. And the only thing that multiplies to give me 7 is 1 in itself, so I stop there. I see 2 7s, so I cross 2 off, write 1 on the outside, and my leftover goes on the inside. So my answer to this problem is 7 root 2. Now, moving on. Down below, here's a multiplication problem. You can multiply this and get the square root of 150 and then reduce, but if you're going to do a factor tree, you just end up refactoring it out anyway. So I honestly would leave it like this, and I would go ahead and say what multiplies to give me 10, 2 and 5, what multiplies to give me 5, 3 and 5. What do I see 2 of? I see 2 5s. This time I have 2 leftovers on the inside, so I write them both down and I multiply. So 5 root 6. Done. Now this problem, there's a couple different ways you want to do these. Sometimes you want to check and see if you can simplify them. Sometimes you want to first check to see if they're perfect squares. I can rewrite this problem as the square root of 36 over the square root of 49. What is the square root of 36? 6. The square root of 49 is 7. Okay, done. Make sure you can't simplify this fraction any further, which you can. All right, I do want you to take a minute to pause the video and try these two U-try problems on your own. Number 2, you do want to write it separate and then see if you can simplify. Now remember, it is okay to have a square root in the numerator. It's just not okay to have a square root in the denominator. Okay, now we're going to talk about making sure we do not leave square roots in the denominator. Rationalizing the denominator. If we have the denominator in any one of these forms, this is what we would multiply the entire fraction by to get rid of the square root. So if we just have a radical in the denominator, you would multiply by that same radical. If we have a plus square root of b, you would multiply by a minus square root of b, so that's the conjugate. It's not the opposite of both numbers. We're only changing the sign in the middle, which is why we call it a conjugate. We'll just go ahead and get started, and we'll take a look back at this chart as we do these problems. Okay, now there's more than one way to do this problem. Some people recognize that they can reduce the square root of 12 and they want to write it as 2 root 2. You can do that and then you have smaller numbers to deal with. But sometimes when the number is not that small or not that large, I'll just get rid of it right away. I'll say, okay, I have the square root of the 12 in the denominator. So I'm going to multiply the top by the square root of 12 and the bottom by the square root of 12. Now when I do that, on top I'm going to get a pretty big number. I'm going to get the square root of 204 over the square root of 12 times square root of 12 is the square root of 144, which is 12. That was the whole point of us multiplying by that root, so that our roots disappear. Now I need to do a factor tree for 204. So if I do a factor tree 204 off to the side, I know that it's 12 times 17. Can't do anything with 17. 12 I can do 3 times 4. 4 I can do 2 times 2. So I end up with having a 2 on the outside and a 3 and the 17 left over on the inside, which gives me 51. So when I write this, I get 2 root 51 over 12. Now, you can simplify outsides with outsides and insides with insides. So think of this as 2/12. How would you reduce 2/12? You would reduce it so it's 1/6. So you have root 51 on top and 6 on the bottom. Okay? All right, now look at these denominators. They're going to get a little messier. So now we have to go back up to our chart and look and see what the conjugate is. So the conjugate of 5 minus root 6 is 5 plus root 6. So I'm going to multiply the numerator and the denominator by 5 plus root 6. Here, we're going to distribute. So we get 10 plus 2 root 6. Now, watch what happens on the bottom, which is why we do this. If we were to FOIL this out, we would get 5 times 5, which is 25. Now we would get 5 times root 6, which is 5 root 6. Then we would get negative root 6 times 5, which is negative 5 root 6. So look what happens to that. The middle terms cancel out. That's why I don't bother writing it. So I'm just going to multiply negative root 6 times root 6. So I'm going to have negative root 6 times root 6 is 36, which is 6. So on the top, I get 10 plus 2 root 6, and on the bottom, I get 19. Now, the only way we can simplify is if I could take something out of the 10, the 2, and the 19, because those are all on the outside. I can't, so I leave this as my answer. Okay, let's try another one. So now this one, we're going to multiply the numerator and denominator by 4 minus root 11. So on the top, I'm going to distribute the 2. So I get 8. Keep outsides with outsides, insides with insides. So that's minus 2 root 11. On the bottom, I know I need to multiply the 4 times the 4 and the root 11 times the negative root 11. So I get 8 minus 2 root 11 over 15. Now, the only thing you would be able to simplify is if I could take something out of the 8, the 2, and the 15. I can't, so this is my final answer. Take a look at the U-try I have for you here. You're going to multiply the numerator by 8 plus root 3 and the denominator by 8 plus root 3. I want you to go ahead, try this, pause the video, and try this problem. Okay, now that we've practiced simplifying, we can go ahead and practice solving equations. Now, in order to solve equations with a squared term, when we only have a squared term, not also an x term, we are going to get the squared by itself. So my goal is to get this term by itself. I'm first going to start off by subtracting 5 on both sides. So we get 3x squared equals 36. The x squared is still not by itself, so go ahead and divide both sides by 3. So x squared equals 12. We're going to go ahead and square root both sides. So I get x on the left. Now, because you are introducing a square root sign, you have both plus and minus. If a square root sign already exists, we assume we only want the positive of it. Reduce the square root of 12, which is 2 root 3. Done. Okay, now let's try this problem. You want to get the squared by itself, so we're first going to divide by 3. I get x minus 2 squared on the left. I get 16 on the right. Now, can't take out any of these terms because of this squared. I have to root both sides at this point. So I get x minus 2 on the left, and I get plus or minus 4 on the right. Now we're going to add 2 to both sides. So look, you have 2 problems here. You have 2 plus 4, that's 6, and you have 2 minus 4, which is negative 2. Those are your 2 answers. Okay, let's try this one. Now it's got a little more complicated. We want to get this all by itself. So I'm going to subtract 1 on both sides, So I get 1/2 times x minus 2 squared equals 3. Multiply both sides by 2. I get x minus 2 on the left, square it, equals 6. Then I square root both sides. X minus 2 on the left, plus or minus root 6 on the right. Now I add 2 to both sides. There's nothing you can do here because these are not like terms. So you can actually leave your answer as 2 plus or minus the square root of 6. Okay? Now I want you to pause the video and try this last U try on your own. If you have any questions, comments, or concerns, go ahead, write it on the bottom of the paper, and I'll see you tomorrow in class.